Hello everyone. Welcome back to MKG Online Study and E-Learning Platform. This is our lecture 3 of Mobile Computing series. Today we are going to study signals, antennas and signal propagation. In the previous lectures, we discussed what is mobile computing, basics of wireless communication, wireless transmission and frequency spectrum. Now, before we go further into advanced topics like multiplexing, modulation, and cellular networks, it is very important to understand how information is represented, transmitted, and received wirelessly. That is why today's lecture is extremely important from both conceptual and exam point of view. So let us begin with the most basic question. What is signal? A signal is a physical quantity that carries information. In communication system, information can be voice, text, image, video. This information must be converted into a form that can travel from sender to receiver. That form is called a signal. So, in simple words, you can remember a signal is a carrier of information. So, basically, when you speak about mobile phone, your voice is converted into an electrical signal. That electrical signal is transmitted wirelessly. At the receiver, it is converted back into sound. Without signals, communication is impossible. Types of signals. In wireless communication, signals are mainly classified into two types: analog signal, digital signal. So basically, analog signal is continuous in nature. For example, human voice. Digital signals are discrete in nature. For example, computer data. Let us understand both one by one. Analog signal. An analog signal is a signal that is continuous in nature. That means it varies smoothly with time. It can take any value within a range. Example of analog signal: human voice, music, temperature variation. Earlier, communication system like radio broadcasting, old telephone system used analog signals. So you are seeing that this particular signal varies continuously with time. So you can have any value anywhere. So analog signal can have every value or any value at each and every point. So this is waveform, or this waveform is smooth and continuous. Next is digital signal. A digital signal is discrete in nature. It has only two possible values, 0, 1. Digital signals represent information in binary form. Example, computer data, mobile data, internet communication. All model communication systems use digital signals because they are more reliable, less noise affected, easy to store and process. You can see that this is the digital signal. In this diagram, there is analog signal and digital signal. So this is the diagram of only digital signal. This is diagram of sine wave signal representation both in analog form and in digital form. Let us now compare this analog and digital signal. So nature wise, analog signal is continuous, digital signal is discrete. In analog signal, noise immunity is poor, means the signal can be affected by noise. But in digital signal, it has a variability that it will not affected by noise. Accuracy. Analog signals are less accurate. Digital signals are more accurate. Processing. Difficulty. Easy. Usage. Radio, old phones, old systems, digital signals, mobiles, computers, modern system. Because of these advantages, mobile computing system always prefer digital signals. What is an antenna? An antenna is a device that converts electrical signal into electromagnetic waves. So basically, you can say an antenna can convert electrical signal into electromagnetic signal and electromagnetic waves back into electrical signal. In simple words, antenna sends signal into air and antenna receives signal from the air. Without an antenna, wireless transmission is not possible. Wireless reception is not possible. Every wireless device has an antenna. Mobile phones, Wi-Fi routers, base stations. These are the examples and they do have antenna. So basically, transmitter is sending the data. Here the data is converted in the form of electromagnetic waves. At the receiver, that electromagnetic waves are received by the antenna and they are again converted back to electrical signals. Next is functions of antenna. An antenna performs three main functions. Transmission of signals. It converts electrical signals into electromagnetic waves. Reception of signals. It receives electromagnetic waves and converts them into electrical signals. Radiation of electromagnetic waves. It efficiently radiates energy into free space. So antenna acts as a bridge between electronic circuits and free space. Antenna are essential components in mobile phones, base station, Wi-Fi routers. Types of antenna. Antennas are broadly classified into two types. Omnidirectional antenna, directional antenna. Omnidirectional antenna radiates signals equally in all directions. Example, mobile phone antenna, Wi-Fi router antenna. Advantages are provides coverage in all directions around the device. You can see here the diagram of omnidirectional antenna that distributed the signal in all directions equally. Directional antenna. A directional antenna radiates signal in one specific direction. Example, satellites, microwave links. It has longer range, less interference. You can see here that their signal is distributing in a particular direction. What is signal propagation? Signal propagation refers to the manner in which radio waves travels from transmitter to receiver. Signals do not always travel in a straight line. They interact with buildings, trees, ground, atmosphere. Because of this, signal strength changes from place to place. Propagation mechanism. There are three main propagation mechanisms: reflection, diffraction, and scattering. Reflection occurs when a signal strikes a large obstacle and bounces back. You can see here from the source signal is extracted and it is hit by a large obstacle, then it gets reflected. So reflection occurs when a signal hits a large obstacle and returns back towards the source or towards that side from which it is generated. Obstacles may be building, walls or mountains. The signal bounces back in another direction. Diffraction. Diffraction occurs when a signal bends around edges or corners of the obstacle. You can see here that this particular signal have to be traveled straight, but it is stuck by an obstacle, then it get refracted from its particular path or the original or the right path. So diffraction occurs when a signal bends around edges or corners of the obstacle. Scattering. Scattering occurs when a signal hits small objects like trees, poles, rough surface. The signal spreads in multiple directions. You can see that basically this particular receiver is receiving, then due to the scattering, the particular signal scattered from every direction. The signal spreads in many directions, that is scattering. Factors affecting propagation. It can be distance, obstacle, frequency, environment. So, distance, the signal gets weak. Signal weakens with distance. If we are having long distance, then the signal gets weak. Frequency, higher frequency to less frequency. If the factor which get affected, that is frequency, get less. Obstacles. Obstacles cause loss and distortion in the signal. Environment. Urban versus rural impact. In urban environment, there are more obstacles. Rural environment also have some obstacles, and due to this, our signal, which is propagating, gets affected. So let us summarize today's lecture. Signals carry information. Signals are analog and digital. Antennas enable wireless communication. Signal propagation affects performance. In the next lecture, we will study multiplexing and multiple access techniques, SDMA, FDMA, TDMA, CDMA. Thank you for watching. See you in the next lecture.